This side is always as hard as any problem we've ever done. This side though is deadly simple. You're always moving at a constant speed horizontally, right? Okay. So now we're all set. Can't we find the x is going to be this velocity times that time? So x is 27.099 times 2.578. So that's 69.9. Write these down. Are you writing these in your notes? I went around last class and there were children that had not even written it down. They just were like little bobbleheads the whole time. Oh, that's right, yeah. I'm doing this, and it's not very exciting, but I'm doing it so you have a good example of one worked out correctly, and then you'll have this one, this arc one. You'll be able to work this one out by yourselves, huh? Little baby steps. Then you'll be able to do homework problems. Yeah, this is arc problem number 2, yeah? Do you guys have that one yet? I'll hand it out before we do it, obviously, right? Okay. So anyway, when you do that, we get this. And now let's see what questions we've answered. Did we figure out the hang time? The time it's in the air? I think we did, right? It's about 2.6 seconds if we had to round it, right? So the answer to the first one is that it's in the air for about 2.6 seconds or 2.578 or something like that. We have 3 digits, so we could say 2.58 or something, right? Okay. Find the range. Well, the range, it goes 69.9 meters. Yeah? Okay. Find the, well, okay, speed at the highest point, the greatest height the ball reaches. Well, speed at the highest point is easy. When it's at the highest point, what is its velocity? What is its velocity? It's something meters per second x direction plus something meters per second y direction. What is it? Think. One of them's 0. Which one? Yeah, the y is 0. This guy's 0. Why is the vertical velocity 0 at its highest point? If it's not 0, it's not at its highest point, is it? Right? It applies. It's the same thing. We've done this before, haven't we? Right? So it's got to be the highest point. If it's not 0, it's not the highest point, right? Okay. What is our x velocity at the highest point? What is it all the time? 27.099 or something like that, right? 27 meters per second. Now, what is that is the velocity. What's the speed at the highest point? Make that into a hypotenuse. What's the hypotenuse of this triangle? I'll draw the triangle for you. It's like over and not up at all. It's 27.099 is the hypotenuse of that, correct? Yeah, it's not really a triangle, but there it is, right? It's the limiting thing, right? So its speed is that it's about 27.1 meters per second, right? If you had to write it as an angle magnitude vector, you'd say 27.1 meters per second at 0 degrees below or above horizontal, right? It's there it is, right? It's the simplest velocity ever at the top, yeah? Does this make sense? This is one of the questions that I ask in the little worksheets or whatever, and there we go, right? How are we going to figure out are we okay on that? Are there questions about greatest height? So write that down so you've got it or something, right? How are we going to figure out the greatest height it reaches? What's the final velocity vertically at the greatest height? 0, because if it's not 0, it's not, right? So all we're going to do is we're going to set up a x, vi, vf, a, and t. And if it helps you, this is the vertical side, right? We're going to go from launch to the top, right? The final velocity is 0. What's the initial vertical velocity? 12.636, right? Our acceleration is negative 9.8. Yeah? We don't care about the time to the top. By the way, the time to the top would be half this time, wouldn't it? Some kids like to do that and then they use the time. I'm not going to do that. I'm going to use this guy here. Doesn't this guy not require time to solve for x? Okay, so I'm going to solve for the highest point using this guy, right? So VF squared is VI squared. Right, so 0 squared is 12.636 squared plus 2 times negative 9.8 times x. So take your calculator and calculate what x has to be. Calculate that. .15 meters. So yeah, if you ever have to figure out the greatest height, that's what we do. So at half the time, it's 8.15 meters in the air. It's moving over this fast. It's not moving up or down, right? Yeah? You guys look, are we good? You have questions? Oh, I did this. I used VF squared is VI squared plus 2AX. Did anybody else get 8.14? Yeah? You got something different? 12.636. Then you divide that by 2 and by 9.8. I just did it in one step. Oh, 4.9. Oh, you're doing 1/2 9.8. You go 2 times 9.8.
Okay.
It's okay. I'm glad we figured out the rift in physics. Are we good on this one? Now I'm looking at you guys, and I can see that look in your eyes. You guys are like, is that all? Is that, you said this was a tough problem. I'm expecting a little bit more, Mr. Murray. Yes? Oh, the range is this. This is how far it goes. T is this. Oh, on this one? Well, there's two things you could do. You could just use another kinematic formula to find T. But wouldn't it just be half of this? Half the time up, half the time down. So don't forget your linear kinematics tricks, right? Are we good so far? Okay, so I see the look in your eyes, and you guys are like, really? That's what you're gonna, that's all you've got? Okay, so here's what I propose. Let's put a wall here, okay? Let's put a wall here at 50 meters. Yeah, I know. Because you want more. I'm doing an example of a varsity question, okay? Oh, no. This is like varsity, okay? We always have to do a varsity one, okay? Because so many of you are talented and gifted. I'm just talented, you know?
Are any of these going to be like on the top of the wall?
Are they what?
Is there going to be a wall?
Yeah, something like that. There'd be like one of those. Okay, so, but the answer to that question is always yes, you know? Okay, so, and the story I'll tell you is this. A friend of mine went to Cornell University in Ithaca, and apparently, and I don't know if they've torn these buildings down now, but there's a U-Haul 1 and a U-Haul 2. Yeah? And somebody took a block of Velveeta cheese and they punted it out a window. And it went through space. And it didn't strike the ground, it actually struck the wall of U-Haul 2 or something like that, right? And Velveeta is sort of this, like glue. Right? You can glue stuff together with Velveeta, right? And it stuck to the wall. And it just stuck there. And there was a piece of that, and it was like way up off the ground because like these dormitories are like very, very tall. Right? So it's not like anybody could get there and like clean the Velveeta off the wall very easily. And apparently it just sort of sat there for his entire time there. It just sort of changed color. It gradually bleached out, you know, kind of sweated a little bit, but it was stuck to the wall of the thing there. So in this case, it's not that we hit the ground, it's that we hit some horizontal thing there, right? So what we're going to do, if we don't have any more questions about this, is we're going to use a lot of this stuff, but we're going to solve for striking that wall. And of course, we want to know how high up the wall